Welcome, everybody. Good morning, good afternoon, good evening to all our viewers and friends from all around the world. We are super excited to bring to you another episode of Simulation Cloud Simulation Champions webinar series, where we actually bring our actual customers from the industry to this episode, and we firsthand hear from them their journey, their adoption of the DS tools, and how that has helped them, and what their future also looks like. So. My name is Ronit Mukherjee. I'm a senior industry process consultant here at Dassault Systems. I'm going to be a co-host today, and joining me is Shri Krishna, my simulation tag team partner, champion over there. So we both of us are going to be co-hosting this webinar. And today we have a very exciting, champion joining us all the way from Peru. And when I say exciting, it's not just about their products are exciting. It's their journey has been very exciting as well. And also, they were on the main stage of the 3Experience World. So what better champion to have on our webinar series and listen firsthand about their journey. So please help me in welcoming Manuel Morales from Resemin. Hi, Manuel. How's it going?
Hello, guys. How are
Welcome,
you
man.
doing
Welcome.
today?
Doing fantastic.
Thank you for
Welcome.
the
We're super
invitation to this
excited.
webinar.
Thank you. Thank you.
Yeah, it's an amazing opportunity for us to show you what we are doing with simulation tools, with the platform, with the 3Experience solutions about the resistance of our machines. It's a very amazing work that we are doing with your solutions.
We're really excited now to hear about that journey. And before we even jump into it, first of all, I would like to thank you for joining us on your day off. It's a national holiday in Peru, and Manuel has decided to spend, the starting of his day with us rather than hanging out with his family and going out for a picnic. So thank you. We are really, really thankful for that,
He
man.
probably
So
Thank you,
likes
Manuel.
mod
Yep.
sim a little bit more than some of our
just a
other
little bit more.
customers.
It's a part of
Also,
the
we have
family.
Jose on the call. Jose is like, he's almost like an employee of Resemin because he's been working so closely with Manuel and Resemin for so many years. We can treat
Right,
I
Jose like our customer today.
I
right.
will
I
ask
mean,
for some money. Yep.
exactly. And the reason why I don't introduce Jose is because everybody knows Jose. Jose is the simulation expert Jose. So welcome, Jose. My apologies. But
Thank you, my
yeah,
friend.
let's
My pleasure.
thank you. Let's jump into it. Manuel, we'll start with just a little agenda. We want to hear about your story, the Resume story, about you, your engineering team, and all the achievements that you've done over the last few years, and the whole history actually would be really nice. We also want to understand, how DS tools helps you. What are the benefits that you guys have seen so far, and what are the benefits you guys are visioning for the future? And once we talk about that, we'll jump into the new, the ModSim type of, talk where you use the cloud simulation tools to, work on Resume, and we'll deep dive a little bit more into those simulation topics. And then we want to we want to hear from you what the future looks like at Resume. What cool stuff are you guys working on? Any cool designs you're making? I'd love to hear about that. So let's jump into it right away. We'd love to hear from you about your Resume story, man.
Yeah, sure. What can I say? Resemin is a company here in Peru that we have about 1,000 employees between administrative people, engineering people, the manufacturing and assembly people. We have right now two factories, one in one part of the city. In this place, we cut the metal, make some welds, painting the parts, and then in another part of the city, we have the assembly factory. We have the capacity to produce more than 20 machines in a month. And we make sales to all the world. We have some machines in Asia, in North America, Europe, Africa, Oceania. Is we get the 5% of the global market share. Is in percent is very low, but if you see the number of machines that we are selling every year is very big for us.
I mean,
And
5% of the market share of the global market share.
that's
That's
a big
pretty big,
number.
man. That's a big number. It's not an easy number. I see those red dots everywhere on the global map. Yeah, your products are basically everywhere. So great job on that.
And also these are
Thank you.
customized machines, right? They're not so identical to each other because you have different demands coming in from different geographies, right?
Yeah, our main sellings are about customized machines because we have an standard. Actually, we have a standard, but we never sell the standards.
Mm.
All the time, a customer comes and say, "Oh, okay, but I need a long arm. Maybe the arm needs to now drill this way," and some crazy things, and we have to develop for them these customizations.
Great, great. Okay.
Maybe tell us about your factory, Manuel. I think his video is frozen. Hey, Manuel, can you hear us?
Yeah, I
I
think
guess
in the meantime,
some issues.
where the internet connects, I believe this is
Maybe
their assembly line.
maybe we can ask their
Okay.
I can
PS
tell
employee.
I can tell you this is the new plant. Uh, is as Manuel said is the new assembly plant, and they are producing more than 20 machine a month. Manuel, are you there?
Yep.
I'm talking about
Yeah,
you
so sorry.
and the plant. So this is the new plant, right, Manuel?
Yeah, this is the new plant in Huachipa, Lima. And if you can see, there are a lot of machines that are assembly right now. Actually, in this moment, they are assembly some machines, and I have a lot of emails with a confirmation of the developing of the machines.
Yeah, you mentioned this factory line can do 20 machines, 20 plus machines at a time, like building them. And if you have to manage all of
Yeah.
that, yeah, that's a lot of emails coming your way, man. I can understand that.
All right. So tell us
Uh,
about different kinds of equipment that you build.
Yeah, we focus in underground mining. It means some we have machines for every single process in the underground mining, making the tunnel, making the roof of the caves, putting the explosives in the rocks in order to blow all the tunnel and get the rocks with the minerals to give to productions factories or maybe some customers. If you see the next slide, please. You can see all the machines that we are developing right now. This is our product range of machines. We have more than 20 kind of machines. The next one is more wide with our production monthly.
Wow, that's a pretty wide range.
And
I was about to say that that's a wide
if
range
you
of
see
machines you guys offer.
yeah, we have, as I say, machines for every process that in the mine is done.
All right. maybe talk about the history of the company from a product development standpoint.
For me, this slide is my favorite because Manuel, tell us what's going on about your exponential growth in the production. That is pretty amazing, and especially in 2009. Explain just a little bit about that, please.
Yeah, it was very. We had very big deals in some years. In the first years of the company, we made only some reparations and customizations of machines that were working in mines. But in 2002, one of our customers asked us for a machine, for a little machine, and this was for us our first project of a real machine. So that burns the Raptor Mini in 2002. Then we start to produce some of these machines, and another customer say us, "Oh, look, I have this machine is bigger than you manufacture, but I need one more similar to that." So that starts another project and start making another machine, and then another customer said, they say, "Oh, I want this machine, but with this kind of work." And uh, with this starts all the customizations. And when we notice we have a lot of machines that we were producing, so we said, what about producing in mass? So starts to grow the sellings and the production of our company. Actually, in 2009, we were only working with very simple tools, and start to working with the Sol solutions in 2010. With these solutions, we start to make more complex works and more complex machines.
I like that. Look at, I mean, their ramp up
It's like this.
from, yeah, that's incredible. I mean, how was the growth of the company that quick, and the amount of, like, the engineers you have to hire, and it's great to see. And yeah, we'd love to talk a little bit more about, what goes when you adopted those simulation tools and SolidWorks tools, how that helped. So we'll deep dive into it a little bit later.
Tell us about your certifications and patents, Manuel.
Yeah, we have some certifications in order to sell our machines in other countries. We have certifications of quality, of security of our machines, and operability of the same. All of these certifications are asked for our customers in order to operate in some mines and in some countries. Think about this machine. Have to make sure that the operator is still alive in all the work that he must to do. Because I don't know if you remember, in Chile where an accident in an underground mine.
Yes.
There was an earthquake, and the rocks drops over the operators this day. The main idea is that the operator can still alive, still secure, and make efficiently his work.
That's important. Like, human factors, making sure, we are alive when we use these types of tools. That's important. Yeah.
Yeah, in order to get this kind of machines, and about customization of our machines, we have some patented designs The most famous of them is the Mookie FF. This is the most uh, how can I
The
say?
smaller one.
Like the
Yeah,
root.
the smaller one. Thank you, Jose. The smaller one in the world with just about 1.5 meters of height. So it's for very small mines, and this responds to the ask of many of our customers, not only here in Peru, so in Mexico, in North America, and in Africa too.
Is your is Mookie FF, is that the best seller out of your list of items? Is that the one that sells the most?
Yeah, one of the most best selling.
Very cool. Very cool. Can you tell us a little bit about your team?
Yeah, in the engineering team, actually, in about 20 years ago, it was only 2 or 3 people making some drawings in the beginning of the company. 10 years ago, we grew to about 10 designers. And with the growth of the company, the department grows too. Right now, we have 18 designers, mechanical designers, 15 electro-hydraulic designers, 5 structural analysts, three, sorry, bill of materials makers, and 2 people in codification. We have a lot of people working with not only the designs, with the managing of the data too.
Yeah, that's a packed team, Manuel. And I'm very curious. You said that 10 years ago there were 2 designers that were doing some 2D CAD drawings. I'm very curious to know, since, or even more than this, like in 2006 was when your first experience with SolidWorks or CAD was happening. From then till here, what does that journey look like for you? How you started incorporating those tools and how that helped you? I'd love to hear a little bit more about that.
When the complexity of our machines starts to grow, the complexity of our tools have to grow too. There are 2 main tools for a mechanical designer and mechanical analyst in the daily work. One of them is the software, and the second one is coffee. So let's take focus in the software.
I thought we were going to
Mainly,
talk about
we
coffee,
start to.
given how good the coffee is in your region.
Yeah, I mean, we can talk about coffee
It's
too,
really
guys.
good. It's really good. So in 2009, we start to use SolidWorks 3D because we need to put our ideas in a better way than only 2D cuts. With working with drawings is very difficult to explain to our boss, to the CEO, how the machine starts to work. When we start to use SolidWorks, the way that we start to communicate the information to the other departments of the company gets better.
Yep.
Then we start to, okay, we are not only copying one machine. We have to develop a model from us. And in this at this point, we start to use simulation tools. Some years ago, we had ANSYS working in the company, but start to see that we need more efficacy and we need to be faster to get the results. So we start to work with SolidWorks simulation in order to only make the modifications and rerun the analysis. And this was a very 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 fast way to develop our models. In one point of our history, we had all the information only in a machine that made the works of a server. It was a machine there
Very crazy,
below
right?
the desk. Yeah, if you remember that desk. And um, uh, think about this. The CEO comes to the engineering office and said, "Oh, who had the last version of the Volta?" And everybody said, "Me." And we start to say, "What?" But your version is not the same than my version, and the chaos starts this day. For this this part of our history, we start to use PDN to manage our information, our data, and starts to make a better behavior of the way that we communicate the information right now. With the pass of the years, we start to make more more customizations, more complexity of our machines. We start to work with some electronic tools that like MATLAB, CODESYS. We start to manage the cables, the wires of our machines with SolidWorks Electrical some years ago, and start to get um, a little bit problem. We need to duplicate our productivity because one customer from one country comes and say, "Oh, I love your machines. How many you develop a year?" More or less 60. Oh, okay. Could you please make 60 for me?
Oh,
60
wow.
more,
Oh
right?
my God.
Love it.
60 more.
That's a big
Oh,
order.
Let's
Nice.
go.
It's a good problem.
okay.
It's a great problem
Yeah,
to have.
a good problem, a good pain of head.
Yeah.
And so we start to need a more complex tool in order to get results faster. With SolidWorks simulation, I can get FOPS test. We can talk about this test later, but this test take us for about 4 or 3 hours with SolidWorks simulation, getting some realistic results. But we need more effectivity. We need the results faster. So we start to looking for a more effective tool, and we see 3D experience simulation starts to use this solution with only two analysts, the only two analysts that were in the company this year, and get some results in very low times. When we make the simulations in SolidWorks, we take about 4 hours, I told you. And with this tool, we get results in only 40 or 50 minutes. It was amazing for us because in a day, I was doing 2 simulations or 2 iterations of the same study. But now with 3D experience simulation, I can get more results and do better things. I can explore some things that in other tools I can't get.
Manuel, this is because cloud computing, right?
Yeah, the cloud computing is
Big.
for us like light in the darkness.
That's awesome to hear.
Or
So
light
what
at the end of the tunnel in your case.
Yeah.
I'm being cheesy here.
figuratively and relatively as well,
Literally.
literally as well. So no, this is a
Literally.
great story, Manuel. Thank you for sharing that. And it's very important to understand like how as a designer, as a company, at each of those steps, you ran into a problem or a situation and you had to adopt tools or bring in tools that can solve that problem. So in what you mentioned in 2009 with the SolidWorks and the simulation collaboration, where you can have your design, send it to simulation to run, change some parameters, and rerun the design as many times as you want, and you'll get your studies out. That's one of the big reasons why people around the world also use that tool. Apart from its accuracy and greatness, it's the collaboration that we can do with the design stuff. And then your the data management journey, and then figuring out the SolidWorks electrical part when you have cables and all that stuff coming into it. That's fantastic. The best is still like, hey, in 2022 we adopted cloud simulation tools, and now we can do simulations a lot faster, a lot complex simulations. So that's incredible to hear. Thank you for sharing that.
All right.
Thank you too.
I guess, moving on, we could talk about one of the favorite equipments at Resemin and how it has evolved over the years.
I love that name.
Yeah, this the CEO of our company is a big he loves dinosaurs, so and he take the name of some dinosaurs to give the name of our machines. Thor is one of our most famous machines. The first image that you see is the Raptor. Our first Raptor is a 1 meter height machine. It looks like a cockroach, but we now are making very, very complex machines like the Raptor 7X that you are looking in the screen. Actually, this animation of the machines turning is made with SolidWorks Composer.
I was about to ask you that question.
Yeah, all of our data and all of our information is made in the platform of the Salt and SolidWorks main. With this machine, we have not only the most resistant, we have electronic development, electric development. There are a lot of work of a lot of people in this machine. It's the bigger machine that we have right now in the development area.
It looks like a transformer.
I like the name.
Yeah.
I guess
something like that.
One quick thing I want to mention. So to all our viewers, I mean, this is some great, exciting stuff that we're showing you. If you have any questions for us, please, use the Q&A chat and just drop some questions for Manuel or for us, and love to answer those questions for you all.
Yeah, you can use the Q&A panel for questions or chat to say that you guys are awesome. We love this information.
Yeah.
All right.
Yeah.
Okay, let's move on. You can tell us about the evolution of some of these machines.
Yeah, these are our new machines every year. If you see, the normal way of a company is to make a prototype, design the prototype, develop the prototype, make some tests in I don't know, in a mine, in the street, I don't know, and then if the machine is okay, start to sell this machine. In our case, don't works like that. We develop a machine, we test the machine in the software, then manufacture the machine with the certainty that this works well in the real world. This is our main target every year. If you see, we sold about 6 new machines, totally new machines, in 2022, about 13 new machines last year. And right now we're developing a 2-arm machine, and one arm make one kind of work, the other arm make another kind of work. We are talking about a machine of 6 meters, oh, so sorry, 8 meters of long, to about 3 meters of height, and wide 2 meters, with the power in one drill of about 5 tons, the other one 3 tons, and
Wow.
to make work in one mine that is underground in Africa, with ambient, with about 50 degrees.
Oh, that's
So
hot.
Wow.
all these conditions for just one machine that we have to sell. We test everything in SolidWorks and 3D Experience, and we have the certainty that these machines will work fine because
By the
of
way, when
our
Manuel
tools.
said 50 degrees, he meant 50 degrees Celsius,
Not
heat in a
Fahrenheit.
mine. That's hot, not
No,
Fahrenheit.
over the machine. So no, we are talking about roasted chicken. No. This is
Roasted chicken.
You know,
Love
I
it.
was also thinking when you're describing how big and gigantic this machine is, since your CEO is fan of dinosaurs, I was curious if the name of this machine is Godzilla.
could be
You
a
know,
better
you know
name
what
that
I'm
we are
It's a great name.
using.
Maybe
yeah,
I
you know
will
what
receive
I'm
a
Godzilla.
gift from Resemin when they name it as Godzilla.
Shurina, you know what I'm thinking? The CEO of Resemin is such a fan of dinosaurs. He's actually making all these machinery to go find the dinosaurs inside, and then this is just a ploy. That's what's going on. Yeah,
That's a
that's
secret
awesome, man.
agenda, secret
Secret
vision.
agenda. Yeah.
Maybe one day. Maybe one day.
Okay, now
Yeah.
I'm curious to ask the $1 million question that we always ask all of our champions, right? Um, you showed in your history in the progression of product development. Initially, there were some standalone simulation vendors and tools that you used, and then you switched to integrated approach, with SolidWorks simulation, or primarily you went with Dassault Systems for simulation. What were some of the key reasons? Um, in going with this approach as opposed to a standalone point simulation tool, which might be extremely good in what it does, but why choose either SolidWorks simulation or 3D Experience Works?
Okay. First, we are not stopping to use standalone tools.
Okay.
We still working with standalone tools to make minor works. For example, I have to make a new support for a tank. I have a designer that is working in the simulation of this component with SolidWorks and SolidWorks. We don't need the power of a cloud computing for just one support. It's like make a surgery of a heart of a bee, so not make sense. So this is your joke, Jose. Thank you for that.
Yeah.
And
That is a joke that Jose would use. Yeah.
yes. But we start to use cloud computing simulations when we have a situation with me, actually. I was working with 2 simulations at the time in my machine, and my computer blows. So I told my boss, Fernando, my computer is on fire. And Fernando said, yeah, it's a very big and very good machine. No. Actually, it's on fire. The computer blows. and we saw that the computer wasn't enough for the simulations that we are trying to do. And so this was the starting point to get a tool that make a most powerful kind of works in simulation, especially. That was our starting point to use regular in regular time the simulations on cloud and all the solutions that give us your platform.
Makes sense.
That's a very, very good point. And it's very interesting to know, like, some of the points, Manuel, you bring up where, you have the SolidWorks desktop tools, the simulation desktop tools, and you have power of the cloud computing and really high-end tools. And it's not like the one is overtaking the other or the other one is overtaking this one. They're both existing.
No.
You're using both, and they're being utilized in a way that they're supposed to. Like, for example, you mentioned for some support, for some entry-level stuff, you use the desktop tools, run quick simulations, and you're okay. Hey, this fixture is going to work. But when it comes to some high-level computing, some drop test analysis or some durability stuff, that's where you go into the cloud computing realm, and also the higher-end tools that you utilize for those simulations. Is that correct?
Yeah, actually, this is the way that we are working right now, and we are working with these solutions too, in order to communicate the information to the analyst. We have about 12 designers working at a time in the office, and some of them ask for a simulation. Right now, we have 3 designers working for in the office, and they are making some new development of some components. And the only way that they can communicate the information to me is to send it for email or maybe with VPN connections, but it's very, very slow. We are using the platform in order to get the information from the designer to the analyst. To make some simulations here, make modifications, and translate the information to them. They are now working with the drawings more faster than before that we are using only VPN or maybe emails.
That's great.
And I think along the same lines, one of the most common questions that comes up, and you partially address this when you are talking about the history, which is, do you find a difference between SolidWorks PDM and the product lifecycle management in 3D Experience platform? I mean, how are you able to manage these two together?
Actually, we have developed PDM very well here in Resemin. We are working with PDM at its maximal level. We are starting to look at the 3D Experience platform to manage our data, but we're starting to get the information in a correct way to translate. We are right now we are not ready to migrate all the information because we had a legacy way to work, and with the platform we have to change our way that we are thinking about the science, the way that we are working. It's a cultural change, not only a change from one tool to another tool. Both have very, very great solutions for every company. I was working before than working Resemin. I was working for 2 SolidWorks resellers, and I saw how PDM works with every company very well. And 3D Experience platform, I was talking with my old partners, and some customers of them are migrating the information to the 3D Experience platform, but the first things that they have to do is get the information in an order, in a correct order, and start thinking more serious on how the information must to be managed. It's more a problem about the people and not about the solution.
That's a good way to put it. And in fact, I remember you mentioning at 3D Experience World that one of the workflows could be that you keep all of your CAD data within PDM, but for simulation related information, you could, leverage the product lifecycle management applications on the 3D Experience platform. Would that be a good starting point so that you don't, corrupt your existing processes?
Yeah, because usually we take off the information from PDM and work in local machine, but now we don't do this because it's very dangerous. If a machine gets on fire again, it's very dangerous for us. So we get the information from PDM, migrate to the platform, managing the simulation data there with the SolidWorks simulation results, or maybe with 3D Experience simulation results, and communicating to our boss, to our engineering manager, the final results, or maybe the final documents about the simulations.
Okay.
But
Yeah.
still working with the production data with PDM, because it's that we are working for the entire company. Think about 200 computers using right now PDM.
So a new customer who's adopting 3D Experience Works for simulation doesn't have to worry about data migration, as they can continue working in SolidWorks PDM, right?
Right.
Okay. Okay. We've got 15 minutes left. Maybe we can take this opportunity for you to quickly tell us about some of the engineering and business benefits that you wanted to share with our attendees.
Yeah, as I said before, the main engineering benefits is that we have results in less time, very complex results in less time, and that means for the company in less money spent in prototypes and physical tests. For example, an FOPS test is about $8,000 to $10,000 for each physical test. So only the certification, and but we have to manufacture the components for this test. It's about another $10,000. So we are talking about $20,000 for only one test. Imagine if I have to make 3 or 4 tests, physical tests for one machine. No, it's
Manuel,
very expensive.
I'm imagining that because this is a certification test, you cannot fail at that certification test, right? Because if you fail,
we don't can fail.
That means that your time to market will be take much longer, and you will lose maybe your business, right?
Yeah, could be 2 or 3 months more of development, and now for our customers, of our kind of customers, is very dangerous this time.
Yeah. Manuel, quick question for you. We have one of our guests with this question, and because we're talking about physical tests and simulations and stuff, what Francisco Gutierrez wants to know is, after we make after you guys run the simulation on our tools, do you make any physical test, or do you make some physical test, or one or two, or give us a little bit more about that, or do you just take the results from simulation and you go produce?
We take okay. We make all the testing in simulation. We have the certainty that the results are okay. So we send the components to manufacturing and maybe make some tests in the factory, but not big deal. The only one certification that we made with a physical test as that is the FOPS, because it's a worldwide certification, and the company that certificates us is asked to us the physical test. So we have to do it, but we have only one iteration in physical testing.
Great. That's great.
So
So just to
Ronit,
validate.
just in terms of numbers, right? What Manuel was saying earlier, even if it takes $20,000 per test, so instead
Yeah.
of 5 tests, if you do one test, you've already saved
Yeah.
$80,000, and that's
That's
just for
Mhm.
one machine. And there are like so many machines being produced by Resemin, so it's a big multiplication factor.
yeah, absolutely. So
Yeah.
Right.
it's a great point.
Okay. Speaking of the safety, maybe we can quickly discuss how the unified modeling and simulation, or the ModSim approach, has been adopted at Resemen, starting from requirements and collaboration and modeling and simulation. Tell us about the key requirements that you always like to talk about, which are critical to Resemen.
Yeah, no, for us, it's very critical to get components with good durability. Make the operator is safe in our machine, and try to get new configurations in order to customize the machines to our customers. This is our main point of work for us in the engineering department. If you see the next slides, we are doing this with some kind of simulations, with linear statics, with durabilities, with optimizations, in order to get a
Like we
Ah,
lost you
I
there.
guess.
right as we were saying, in order to do that. Sorry, Manuel, we lost you there for 1 second.
Oh, okay. I was talking about this.
That national holiday internet problem that happens everywhere.
Yeah.
Everybody is watching Netflix at this
Yeah,
time.
exactly.
The complete system to the analyst. So, can you hear me well?
Yes, yeah. Maybe you can
This is
also.
nice.
Yeah, this is like one of my favorite slides.
And to answer actually Francisco's question as well, here's a physical test that we're doing. So we, of course, we recommend, like, run the simulations, bring the iterations down, we'll do one or two physical tests, and you have a working product.
Tell us about this particular case, Manuel.
This driller machine, with this, we are testing if the entire arm are ready to the work of the driller. The driller is shooting the rock with 3 tons, 48 times at a second. So imagine that power in one driller, and the structure resisting this work, not only here in the surface, imagine in the mine, when there are rocks dropping over the machine, are very hard conditions to the machine. So we have to get we have to get a very safe component For this kind of simulations, we are using some sensors, accelerometers, to get real-time information about accelerations, and put that information in our simulation tools to get more realistic results. So this is why we are very confident that our first development is okay.
So you're taking
Because
the
this
real
is,
world data from these accelerometers, the loading data, and then you're applying
yeah,
it onto a linear static simulation to get a sense of how long is the product going to last? What is the life of the product? Right.
exactly.
And in a solver time of 2.5 hours, that's insane.
I was just looking at like the number. That's like a 600,000 elements and solving in like 2.5 hours. That's not bad. That's pretty good.
And you also do a lot
Yeah.
of parametric design study, right? Tell us about it.
Sorry?
You also do a lot of parametric design studies, right? Optimization studies.
Uh, yeah, we made, for example, we parameterize some the
Features.
the size, yeah, the inches of the sheets metals, the tubes, some components, the contacts. We parameterize some of these conditions in order to optimize, for example, the position of the regulators of the arm. If you see, this is a telescopic arm. This make this kind of behavior. We have to make sure that the regulators put the arm in the correct position. So this parametrization is made with this kind of tools in order to get a very good component, final component.
Okay, makes sense. And moving on, tell us a little bit about the FOPS test. What is the intent of the engineer and what is the typical process?
Okay, imagine that a rock of half ton is dropping from the roof of the mine, and you are around that.
No,
You
I don't
have
want to
You don't
to
want to
imagine
be
that.
run
around
to a
that.
safe
I
place.
don't want to imagine that at all.
So, so if the operator is under the roof, he will be safe to this accident. It's not like, do you remember Speed Runner and Coyote?
Ah, yes,
Oh,
yes,
When
yes.
Coyote have
yes. Yeah, drops
yeah,
the rock.
something
Yeah.
like that, but but with a safer component, no, with a safer machine.
Okay. And
So our yeah.
yeah, go ahead. So this is the physical test, right?
Our Yeah, this is the physical test, and we make the simulation as well, and the results are very similar. Think about if a physical test, the result is a deformation of about 10 millimeters. In simulation, we have 9.5 millimeters. So it's very, very close, the difference in the results. And if I get this accuracy in only 2 or 3 hours, for us is the
That's
better
great.
way to stay with the correct way of work.
Yeah, and for those of the audience who may not be familiar with this physics, it's a very complicated physics. You have nonlinear impact that's happening, and it's a very short duration, and then there is contact. So it's a pretty crazy simulation. And the fact that you're able to get it accurately spot on, I think credits to the Abacus solver, and also get a faster result because of cloud. I guess that pretty much answers why your current process involves a lot of virtual simulation and just one physical test to make sure that it's passing the FOPS requirement.
Yeah, only for the signing of the company.
There you go. Yeah, that's excellent. So it's a combination of accuracy, cloud compute, and being able to, have this virtual twin where you do a lot of testing upfront. I think that's a very nice, accomplishment you guys have made.
Yeah, and I mean, I always see that comparison between that simulation and the drop test.
Yeah.
That's a nice nice piece of eye candy, man.
I remember very well this case because Manuel used to have use some desktop tools, and I guess this simulation took more than 4 or 5 hours to be solved. And the first the first simulation that
No,
It's four or
more
five
the
more
days.
first
right?
simulation was about 2 days
Oh my
in
goodness.
2010.
And at that time, we delivered the full power of cloud computing using the 100% power, and it took 15 minutes. So it's
Yeah,
it,
this
it was crazy. I remember you, Manuel, and Fernando asking about time, and he couldn't believe the amount of time that he can reduce for, as you
Uh,
said, production, and not only simulation time, the
yeah.
ability of running more models, right? Because if a model takes you 2 days, there is no way to try more than 1, 2 models.
uh,
But if takes you 15, 20 minutes, you can run more optimization. You can reduce your mass in the model. You can do more, right? So that was one
yeah,
of the
That's actually a very good
benefits.
point. Yeah, because you can innovate more and faster.
Yeah,
yeah,
that's it.
And what about the fact when you run a simulation on, this is on the cloud, so you can send simulation on the cloud and still be productive as an engineer in your day-to-day stuff. You're still doing your work. Whereas if you're running an important, like in a
Very good point.
pretty intense simulation that bogs down your laptop, you're not doing any work. You're going out for lunch and coffee, and so it's important to,
no,
you can't do
you
anything at
can
that point.
only pray.
Yeah, pray and
You
eat.
can only pray for the
Pray and
please
runs.
don't blow, please don't blow.
Yeah. So
No,
all great point.
that's a good point too, right? You're not locked to your machine, you're not locked to your application. You can continue working on design while simulation
Yeah.
is uploaded to cloud. Yeah,
Right.
absolutely. Okay, gentlemen, we are at the almost at the edge of the hour. There are a couple of minutes left. Manuel, we wanted to hear from you. You've come a long way in developing simulation processes, leveraging unified modeling and simulation at Resemin. You always talk about the democratization, which is empowering designers with component level simulation
Mhm.
so that you can, as an analyst, focus on more complicated, complex things. Tell us more about it.
Yeah, right now, okay. Last year we were only two people working with simulation. This year starts a team. We have 5 people only developing simulations, and the rest of the designers are starting to use SolidWorks simulation in order to get their own results. So. We are spending less time in the developing of the simulation because the designer is starting with that, and we have to make 1 or 2 iterations only to get sure that that is correct the results, and then launch the information to the drawings for production. It's is a faster process for us, and we are more efficiently than before. So this is what we are doing with the designing area in Resemin. We're getting better results. We are getting better designs, and we are spending less time for each product.
Yeah, makes total sense. So your designers are using simulation upfront at the component level for some of the simpler analysis. So when you get the assembly, it's already in a much better shape, much more optimized shape.
Yeah, spending less material to reducing the cost of the machine and the reduce of the process as well.
Right. All right, let's wrap this up. I mean, clearly you talked about durability, safety, being able to pass the compliance with mostly virtual validation and just one physical test to pass, and then democratization of simple structural analysis. Let's talk about your future projects and then we can wrap up today's session.
Yep.
Yeah, sure. We are working right now in optimization of our cabins, our closed cabins, because most of the mines around the world are starting to make to work with more harder behavior of the ambient. So the closed cabins are more popular, and we have to make sure that the interior of the machine is not is not oh, okay, the operator will not become a roasted chicken. He must be
I
fresh
like that.
in his work.
It must be a fresh
So
chicken.
we're
Fresh,
yeah, fresh fish and not
Fresh
roasted
fish.
fresh and
chicken.
There you
happy.
go.
Fresh and happy.
So the air conditioning of the cabin is very important for us. So we're thinking about work with fluid simulation with CFD. With electromagnetic simulation too, because of some electronic development, electronic components in order to get information long distances, or maybe with remote control machines. Think about controlling this machine with PlayStation
Wow. That sounds
control.
cool.
Maybe
That's fun.
It
it could
reminds
be
me of
cool.
those movies where bomb diffusers are these
Yeah.
tiny little robots.
Yeah.
I
Yeah,
can do
blow
that.
the
I
rock,
can
blow
do
the
that.
rock.
Jose wants to try
And
Yeah.
It's like, I'm certified to drive this now.
it.
and we are working in ordering the information to migrate some of the information to the platform, because we know that this is the future of the managing of the data and the information. It could be very great for us, but we have to take the correct steps in order to take the correct decisions
Right.
to migrate this information with the correct persons and in the correct time.
Yeah, makes sense.
No,
So
brilliantly said.
streamlining process, adding newer physics and creating newer, innovation. Very, very cool stuff.
That's one great thing I want to just mention before we take off. Like with the tools that we have at Dassault Systems, like we have a lot of tools. Even sometimes you might not know what we have. So it's great to understand what our portfolio looks like. We just don't do structures. We do CFD analysis, we do electromagnetics, we do plastics injection molding, and quite a lot of stuff. So it's great that, Manuel, you're always like reaching out and you're always seeing what technology we have and what we can use or what you can use on your end to optimize your design. So thank you
Yeah.
for sharing this journey and this knowledge with us.
Yeah, and you have power of Mr. Jose Pereiras, who's
That's
like half employee of DS, half employee of Resemin.
yeah.
No, we have a lot of fun with Manuel. It's amazing what these guys do. So it's a pleasure for me, to learn from them every day, and how they the product that develop is pretty amazing. So thank you, Manuel, for being here and sharing your knowledge. Is very useful for us.
Awesome.
Thank you for the opportunity for this webinar and the opportunity to show what we are doing right now.
Yeah, Manuel, it's always refreshing and exciting to hear from you. And thank you for joining us on a holiday. And
Please go
and
enjoy the rest of your day and
absolutely.
go for a picnic or something.
Yeah, I will finish the webinar and start to look Peppa Pig with my daughter. So
There you go.
it
Nice.
will be a very good day, a
Very
very
good.
funny
I'll
day.
send you a step file for Peppa the Pig. Remind me, and then you can 3D print it for your daughter. I have one.
Okay,
I'll send one for you.
could
Yeah.
be very pretty. Thank you.
Share it on a dashboard,
Yeah,
Ron.
we'll share it on the
Not a
dashboard.
step file.
Yeah.
Yeah,
Awesome.
yeah. I will send you by Trade Experience platform.
Perfect.
Yes, there you go. On that note, we're going to wrap up today's session. Thanks, Manuel, Jose, Ronit, obviously. And thanks to all the attendees. I hope you enjoyed this session.